This is section 2.3, part B. It's a shortcut for certain types of polynomial division, and it is optional. If you'd rather do just the process that we've been doing, that's fine. You don't necessarily have to do this. This shortcut is very specific. It only works when we're dividing a polynomial by a binomial in the form x minus r. So I'm dividing by a quadratic, I can't use this. If I'm dividing by 2x minus something, I can't use this. It has to be x minus r. Now I will mention it could actually be x plus r, because of course we can think of minus r as minus a negative, which would turn it into x. This process is called synthetic division, and I'll just give you a little look at how it works, and then you can decide whether you'd prefer to learn it or if you'd prefer not to right now. The only example that we've already done that works with synthetic division is actually this very first one. The reason it works, notice the form of the denominator, x plus a number. All right. If I think of this as x minus a negative 5, the value of r is the negative 5. That's why we like to think of it in the x minus form. So I'm going to use r of negative 5, and my very first step is to take that negative 5, and I'll kind of put it in a little box. All right, next I'm going to put just the coefficients of the dividend or numerator. I have 1x cubed, 3 for the x squareds, negative 6, and then 20. Notice I didn't write out any of the x powers of x. I just wrote the coefficients. All right, here's the pattern for synthetic division. I start by bringing the first coefficient down, the 1. Then I'm going to multiply. 1 times negative 5 is negative 5. Put it over there. And then add those. Negative 2. I'm going to continue the same process. Multiply, add. Multiply, add. So negative 2 times negative 5 is positive 10. Add and get 4. Multiply again. 4 times negative 5 is negative 20. Add and get 0. This last value is the remainder. So in this particular problem, there is no remainder. The remainder is 0. Division came out evenly. And then these numbers are the coefficients of the quotient. I like to work backwards. 4 is going to be my constant term. The next one would be negative 2x to the first. And this one would be 1x squared. So I got the 1, the negative 2, and the 4. Those coefficients of my quotient. And that's actually the final answer. The answer to this division problem, x squared minus 2x plus 4. Notice we got that exact same answer by long division in part A of this section. So these are absolutely duplicating situations. You don't need to know both, but long division works every time. Synthetic division is a nice shortcut, not nearly as much to write out here, but again, it only works in specific situations. All right, let's practice the synthetic division a couple more times. Here, x minus r is on the bottom, and it looks like it's the correct form. I just have 1x. And the r is going to be the 1/3 this time. It's already got the minus. So I'll put my 1/3 in my little box. And then my coefficients. 6, -5, 2, -2. I start the process by bringing down the 6. Then I start this pattern of multiply, add, multiply, add, multiply, add. Multiplying. 6 times 1/3 is 2. If fraction multiplication is not your forte, you can always use a calculator to do that. And then add. -3. Multiply. 1/3 times -3 would be -1. And add. 1. Multiply. 1 times 1/3 is 1/3. And add. -4/3. Again, always feel free to use the calculator for the fraction arithmetic if that's not your cup of tea. And obviously it's not mine because I added that wrong. I'm sorry. -5/3. There we go. I was thinking of this as -6/3 plus 1/3 is -5/3. All right, this one did not come out evenly because it does have a non-zero remainder. So, if I were to write this, my last piece, the remainder, could look like -5/3 over x minus 1/3. Then working my way back, a constant term of 1, -3x to the first, positive 6x to the second, just increasing the power every time. All right, one more example of synthetic division. Again, I do have the right form. Notice it's just 1x minus 4. Got the minus, so r is 4. And I'll go ahead and put that in my little box to start my synthetic division process. Now here, I want to be careful. I definitely, when I think about descending order, have missing pieces. So I'm thinking, okay, x to the 4th, but I would have 0x cubes, and then -10x squared minus 22x plus 0 for the constant term. So I'm going to put all of those into my synthetic division. 1, 0, -10, -22, 0. All right, let's go. Bring down the 1 to get us started, and then it's multiply and add. Multiply to get 4. 0 plus 4 is 4. Multiply to get 16. -10 plus 16 is 6. Multiply to get 24. Adding those gives me 2. Multiply 2 times 4 is 8. And 0 plus 8 is 8. Once again, this last term is always the remainder, so once again it did not come out evenly. I've got a remainder of 8. I'll write that in fractional form. And then work my way back. 2 is the constant term. 6 would be x to the first. 4 would be x to the second. And 1 would be x to the third. I don't actually need the 1 there, of course, but just kind of wrote it in for emphasis. All right, there's my quotient. So synthetic division is quick. I don't have nearly as much writing to do, which is a really nice advantage. But do keep in mind it's still limited. It only works if the denominator is just plain old 1x plus or minus some constant.